Let's write our accept challenge subroutine now. So this one's going to start out and it's going to be pretty similar to the create challenge subroutine that we just wrote. So we'll start out by saying sequence here, and we'll start out with a series of checks. The first ones are actually going to be the exact same because when we accept a challenge, that means we are the opponent and someone has challenged us. So we need to respond in kind with a wager, right? So we're actually going to, again, have a group of two transactions. The contract call is going to be the first of those transactions right here, and it's going to expect there to be another transaction in the group. That transaction will be the wager payment transaction, and we'll check the rekey is 0 for all of them. Then I'm just going to steal these guys right here. We're going to start another assertion and expression here. So we'll just kind of use that as a template here. So we're going to check the wager payment transaction again. We're going to check that that second transaction is a payment transaction, that the receiver is our application's wallet address, and that we're not going to be closing the account at all. So that looks good. We also need to check one more thing here, and that is the amount, because this needs to be a wager that is responding, in kind to a challenge. So it should be, the amount should be exactly equal to the amount that the challenger added to their challenge. So we can read that by saying app.local get. And now recall that whoever's calling accept challenge is going to be what we're calling the opponent, and the challenger is obviously not going to be the sender of this transaction. So actually we need to take the opponent's or the challenger's address from that list of accounts that we get along with our transaction calls. So this is going to be txn.accounts1. That's going to be, so that second account is going to be the challenger's account now, because we're switching from the challenger calling. Now the opponent is the one calling this transaction here. So local get from the challenger's account. All right. And what are we getting? Local wager. That's what we're getting. And we want to make sure that the amount in the wager transaction that the opponent is sending is equal to the wager that the challenger proposed. All right, so there we go. We have checked off the wager payment transaction. Great. Some other things we need to do is check that the opponent is actually accepting a challenge from a real challenger. So we should make sure that this account right here is actually a challenger's account. And we can do that by two steps. We're going to first make sure that that account has opted into our app. So we'll say app.optedin. What account is it? It's that account. And what app is it? It's this app, global.current application ID, like so. And then we need to make sure that not only has this account opted into the application, but they've also challenged this person who is now accepting a challenge or claiming to accept a challenge. So let me just comment this. We'll say, check that opponent or that challenger account has opted in. All right. And then we're going to check that challenger account has challenged this account. And we'll do that by saying app.local get. We're going to be getting from txn accounts1, one, and we'll get local opponent, and we need to make sure that that is equal to the transaction sender, because the sender right now is the opponent, the person who is challenged, and they are now accepting the challenge. So let's space that out a little bit. And then we need to do two more checks. We need to check the arguments. So I'll say txn.application.args.length. We need to make sure that that is equal to 2. And then we need to make sure that that argument is actually a valid play. So it needs to be a lowercase r, p, or s. And so I'm going to write another subroutine. We'll call it isValidPlay, and we'll pass in the argument txn.applicationArgs, pass in that second one there, and we will just validate play. We'll say validate play. Now let's write this subroutine isValidPlay. Whoop. So let's create a subroutine here. We'll say subroutine, and this is going to return a Boolean, or in PyTeal terms, that's just an integer. So teal type .uint64 def is valid play. That'll take one argument, play, it's an expression, and this is going to return a Boolean. So we'll return, let's say sequence, because we're going to put some other code in here, return, and inside of here, we'll say or, and we're going to want to check and see if the first character of our play is an R or a P or an S. So we need to do some Byteslice manipulation, and for that we're going to need to use a scratch variable. So I'll create a scratch variable here. I'll call it first character, and that will be equal to a scratch variable. Put the type in here, teal type dot bytes. Perfect. All right, now let's load something into that first character, or store something into it. First character dot store. And what are we going to put in here? Well, it's going to be a substring of that play that we pass in, because we only really care about the first character. So we'll say substring of our play here, and it's going to start at 0 and end at 1. So that will just give us the first character. And now we just need to check and see if first character.load is equal to bytes R or P or S. There we go. There's our isValidPlay subroutine. So we call it there, and then after our assertion has completed, we're going to do something very similar to what we did in our create challenge subroutine. We'll just paste those lines here, and since transaction.sender is now the opponent, this is still fine. We can leave it. The only thing we really need to change is right here. We need to say, instead of commitment, because commitment is the hashed one, we need to say local reveal, and that will be our second argument right there. All right, that should be good. Let's check it out. Let's make sure it compiles, and then we'll continue on. So we'll test our compilation here, and we got a compilation error. So some of you may have noticed when I made this error, but let's see if we can deduce where exactly this error is coming from. So it says here attribute error, int object has no attribute type of. Now these errors can be a little bit difficult to read, but we can kind of look back here and see that it sprang out of when we were executing an equality comparison. And this right here is a Python type. So this is essentially telling us that somewhere where we executed, or where we wrote some PyTeal that was executing an equality test or equality comparison, we accidentally used a Python int object instead of a PyTeal expression. And the place that we did that is right here. So we have this equality going on right here. And here we have just a raw Python 2 integer instead of wrapped in the PyTeal int right there. So that was our mistake. And now it should build just fine. Wonderful. All right, let's go over here and deploy it. I have my little deploy script here. Copy that, paste it in there. All right, we're deploying. All right, created an app with index 1. And I'm actually going to pop open this, and we're going to be playing around with the config to make sure that our checks are working properly. So let's quickly opt in our accounts to this app. So we'll say goal app opt in. And this will be app ID 1 from our first account. Pending. And then we'll opt in our second account. And then we can run our challenge. That's at data contracts, RPS, our challenge. All right, we already went through this script. If we take a look at the accept script, it's something very, very similar. We create the application call, send and output that to a file instead of sending it to the network. We create our payment transaction and output that one to a file as well instead of sending it to the network. Then we concatenate them together in a file. We have goal group them together, assign that group ID to all those transactions, split them back apart, sign each of them individually, and then concatenate them all together again. And finally, we send the grouped transactions. So fairly straightforward, very similar to what we did in the challenge. And right now, if we were to run the accept script, it would hopefully work properly. But let's check first and make sure that everything is, that our checks are actually going to verify everything. So the first thing we're going to try and do is change the wager to be only one microalgo different. And in fact, it's more. So if the contract were to accept this, it would only disadvantage the opponent who's accepting it. But let's still give it a try. So we'll run our accept script here. All right. And it rejected it. All right, that's good. Replace that with a 6 again. And the other thing we're going to check is make sure that our play is being validated correctly. So if I were to replace this R with an invalid play, like maybe a 0, try running it again, we should get a rejection. Looks like a rejection. Put that R back, and now this should be valid data. So this transaction, this accept transaction, should go through. And it looks like it is going through. All right, wonderful. Okay, the last thing we're going to do is read that state. So we'll say goal app read local from. In this case, we've already written the relevant stuff that's affecting account 1, so we only care about account 2 right now. And we'll say app ID 1, guess format, and see what we got. Let me just stretch this up so we can see what's going on. All right, so our commitment is empty. That's correct because the opponent doesn't have a hashed play. They just have a reveal, which is right here, and that looks correct. There's our R, which is a valid play. The opponent is correct. If we go back up here and we check there, the opponent's opponent is the challenger, so that's the correct account, right? And our wager, 1, 2, 3, 4, 5, 6, that is the correct value as well. All right, we have successfully written our accept challenge subroutine.